Good Monday morning to you all. It is Monday, May 4th, 2020. If you're a Star Wars fan, I think this date is probably pretty fun and important to you. People will say, May the 4th be with you, right? Today's math lesson is all about line plots. A line plot shows the frequency, that means how often. It shows the frequency of values or numbers in a set of data. A line plot shows the frequency of values or numbers. If we are collecting information and we have a list of information, sometimes it's far easier to understand the information or the data if we make what's called a line plot. The line plot, can be used to answer certain questions about the data more easily. Above, I have a few line plots to show you. This may take some of the mystery out of line plots, and you may think, oh, I've seen these before. It's simply one axis or line. This one has arrows on the end of it. This one does not, but it's a horizontal line with a title and labels under each one. This is the number of candy bars. This is the number of students who have that many candy bars. So in this line plot, I can see that there is one student who doesn't have any candy bars. One student has one candy bar. One student has two. Three students have 3 candy bars each. Nobody has 4. Now look at this value. How many students have 5 candy bars here? 1, 2, 3, 4. 4 kids have 5. How many students have 6 candy bars? You can see that's 2. One student has 7 candy bars, and 2 lucky students have 8 candy bars. Here we have the numbers of cars sold on each of these particular days, and I could ask you a question: on which day are the most cars sold? And you could easily look at the line plot and say, oh, I can see Friday is where they sell the most. On which day do they sell the least amount of cars? That's quick and easy to see on our line plot that it is in fact Thursday. As you can see, a line plot makes numerical information easier to read or interpret. That's our math word. We are interpreting the numeric data or the numerical information. Let's take a look at this comparison. On the left, I have the number of candy bars sold. This is the same numerical information as this. Which would you rather look at? If we only had this list in front of us of the numbers of candy bars sold by this many students, I would have just written down everybody's answer of how many they sold. And now if I wanted to ask you a question and said, how many kids sold 3 candy bars? Oh boy, I'd have to look through this list. 1, keep looking, 2, keep looking, 3. It takes a lot longer. It's a lot easier to make mistakes when your data is represented this way. We could take these same numbers and put them on a nice line plot with the values 0 through 8, because I noticed 0 was my lowest in this list and 8 was the highest number of candy bars sold, and then I would plot each one. Since there were 3 3s, remember I counted those? Above the 3, I put 3 X's. Since there are 1, 2 8s, you put 2 X's over 8. Now if I asked you a question and said, What's a number of candy bars that nobody sold between 0 and 8? You could see easily, oh, there's no 4s. Nobody sold 4. Which number of candy bars did people sell the same amount of? You would say, oh, 0, 1, 2, and 7. Or you might say, oh, I noticed that 6 and 8 have the same number of students who sold that many candy bars. It makes numerical information, such as this information, much easier to interpret or understand when it's in a line plot. Here's some numerical information showing the number of students in each 5th grade class. Well, I can look at this list and see, oh, there must be 6 sections of 5th grade in this sample school. But to answer other questions, answering questions about this list would be much easier if it was arranged in a line plot. So we'll scroll down and see the same information arranged in a line plot. Now I could probably answer some questions like, how many 5th grade classes are there? Well, we figured out before there were 6. 1, 2, 3, 4, 5, 6. How many children are in a class with 32 students? I think this should be how many classes have 32 students. And we would say 2 classes have 32 students. I would say, which number of students does appear the most frequently? So I would say, well, 27 and 32 are tied because they each have 2. We don't really have a winner. We would say 27 is a frequent number of kids in a class and 32 is a frequent number of kids in a class. I'd like to show you this example. You will be doing some line plot task cards in your assignment today. So let's do this one together. I see a note off to the side telling me that the light green boxes that I see are the text boxes. So if I scroll down on the slide, this is where I will type my answers. It says to use the line plot to answer the questions, and then it says to drag the color-coded shapes to the appropriate spot on the line plot to prove your answer. Let's take a look at that. Here's a line plot showing the number of televisions in a home. This is remarkable, right? That anyone would have 7 televisions in their home? That's amazing. Looks like 3 is the most frequent number of televisions that people have in their home, which to me sounds like a lot because we're a family who only has 1. The question says, how many children have 3 televisions in their home? 1, 2, 3, 4, 5, 6. So I go down to number 1, I click in, and I write 6. And now I drag this color-coded box next to number 1. I'm dragging it right here. Okay? That just kind of shows this is where my eyes were looking when I did that. Number 2, how many children were polled or asked to collect this data? Well, let's see. I have to count all of the X's. So I did a quick count and saw that there's 21. So the answer to number 2 is 21. I type it in the green text box, and I'm going to drag this up to where I found my answer. And you might think, well, how am I going to show that? I can't really make it over the entire line plot, but look, we can kind of drag it. Let's do this. Isn't that kind of crazy? But there you go. My eyes looked here. That shows me where you looked. What is the smallest number of televisions a child had in their home? Okay, not the smallest amount of students who had that, because only 1 student had 5 and only 1 student had 1. But the fewest number of televisions, down here says numbers of televisions, that would be 1. So I'd scroll down. I would put, oh, I scrolled too far. There we go. I would put a number 1 in my box. And now I'm going to drag this circle. Where did my eyes look? My eyes looked right here. Okay, that's how you do a line plot task card, and you will have 3 of those to do in your assignment today. Our first line plot task card says all of the houses on one street were polled to see. Polled means asked, all right? They were interviewed and asked, we say polled, to see how many animals they had. So this is how many animals they have in the home. You can see here 2 houses have 6 animals in the home. You will have questions to answer about that. Line plot task card 3 says a street of children was asked how many houses they went to on Halloween. So if I look here, the number of houses, so this many children went to 5 houses on Halloween. This many children, 3 children, went to 20 houses on Halloween, and 1 child went to 30 houses on Halloween. You'll have questions to answer about that one. And your last sample is a teacher made a line plot to display the number of answers each student got correct on a 5-question quiz. So this shows the answers correct on the quiz. This many students got all the answers correct. This many students got 0 correct. So that's good, right? Nobody got 0 answers correct on the quiz. You will answer the questions below. And finally, today's assignment will end with a paper that looks just like the papers we would do in our classrooms. And it has a little explanation about this first line plot that you have. You can see they involve fractions of an inch, some of our measurement. And it asks how many saplings were there. Saplings are baby trees. How many saplings were less than 9 inches tall? Well, here's 9 inches, right? So when you're looking at this later, less than 9 inches means all of these dots, all of these dots, and all of these dots, because all of this line plot is less than 9. And you will simply answer inside of these green boxes. And what is the combined height of all the saplings? Oh, Mrs. Smit, does that mean I have to add 8 1/4 plus 8 1/4 plus 8 1/4? Yes, you will. You're actually going to have to add fractions. See how that goes, okay? At the bottom, I hope that this works out and is kind of fun. You will be making a line plot about the weights of the puppies. And so I started, because you have to label, right? You're going to label each of these. I found that the lowest weight was 3 1/4 pounds. And then I look at the next highest weight, and I'm going to click in the box and I'm going to write 3 1/2 pounds. And then I'm going to write the next weight is 3 1/4 pounds. You can see that I have filled out all of the amounts from least to greatest, looking here. And then it says here that I can drag the dots. So I already started for 3 3/4. I dragged the dot here. For 4 1/4, I dragged a dot here. Now I have 3 1/2. I'm going to click and I'm going to drag the dot down to 3 1/2. And when I'm finished, I want you to write a question that could be answered based on the line plot and answer your own question before turning in your assignment.